Hi, I'm John, and welcome back to my garden scale Climax project. In the last episode, we completed the installation of the battery, Bluenami decoder, and the associated electrical system components, including the power switch, charging jack, and fuse. The model still needs some cosmetic improvement, and then there's also the problem Trevor discovered in the drive system that needs to be addressed. I've included affiliate links in this video's descriptions so you have access to the same kind of tools and supplies that are being used in this series. So let's head over to the workbench and see if we can get this thing roadworthy. So you may have noticed throughout the series that this model's in pretty rough cosmetic shape. Whoever owned it before I got it decorated it with all kinds of little accessories. Well, I don't like the way they did it. The first problem is that the stuff, to me, looked kind of random, and a lot of it didn't make sense to me. So I've removed all of it. The glue was really blobbed on. Here's a pro tip for anyone gluing stuff on models like this. A little goes a long way. Giant blobs of glue look terrible, and they don't hold anything any better than just a small dab of the right kind of glue. So to complete this process, I used an X-Acto knife and a dental hygiene pick, scraping as much of the solidified glue blobs off as possible. I removed all the details that are easily accessible, like the number plate, bell, and grabs, and I masked everything else that shouldn't get paint on it. I got a can of satin finish black paint with an adjustable spray nozzle made by Rust-Oleum, and coated the model with several very light coats until it looked good to me. Now that it's looking better, we'll see what Trevor has in store for it.
So for those of you just joining us with the project, my name is Trevor Park. I am from the Fern Creek and Western Garden Railroad, and I've done numerous battery conversions, and this is the first ever Bluenami conversion I've done. Last episode, we got this locomotive running, but unfortunately there were some problems with the mechanical aspects of the locomotive completely independent from the battery conversion. These older Bachmann Climaxes were constructed in the late 90s or early 2000s, and the Bachmann engines of that era are notorious for having gear problems. So what we did in the 4 months from the last time we were filming until now is we acquired a parts queen, a locomotive that we're using for parts and harvesting them off that engine to put them on this engine. This is not something that everyone's going to have access to, but it's certainly something to always look for as a locomotive that you can use for parts, as the parts for these engines are starting to become more and more scarce. So today what we're going to do is put those parts on the locomotive, try to fix a lot of the mechanical issues. Basically, the trucks run, but the engine set won't spin, because the trucks are actually motorized. There's a motor in each truck. So we're going to cover how to fix that problem by putting new gears in and putting in a modification that Bachmann released early on after these engines were first released to fix a lot of their issues. And then we're going to put some of the detail parts off of the Parts Queen locomotive onto this engine to make it look a little more spruced up so that it can go out for a run on the Fern Creek and Western and look virtually complete. So let's dig in first to the mechanical aspects of it. We're going to get it running first, make sure we're all squared away there, and then we'll focus on some of the cosmetic problems. Up until this locomotive, I had never actually dealt with one of the older generation Climaxes. Bachmann manufactured newer ones in around 2011, which were far nicer. They had die-cast trucks, all metal gears, and those are really the only ones I've dealt with because I have one of those, and then my older Climax I have had those trucks retrofitted on them, the newer trucks, when I got it. So what I didn't realize is these older ones, they each had a gear in them, and they were both driving the drive shaft, and they were both non-isolated motors. So if one motor in one truck would lose power from the track, the other one would continue spinning. And as a result of that, because both of those trucks were driving the drive shaft, the gears would bind up. The rear truck, or whichever one died, would still be applying power, and as a result it would put an immense amount of load on the drive shaft and would strip the gears out on the drive shaft only, not on the wheels or anything of that nature. So it's not an inherent problem with the gears necessarily, but an inherent problem with the design of the fact that Bachmann had both trucks driving the drive shaft, and if one died, the whole engine wouldn't die. It would just be one truck that would die, and it would bind everything up and strip gears. So that's not a problem for us anymore now, because both trucks are being driven by the decoder in the tender. So if it loses power, which in this case is battery, so it would be the battery dying, isn't a problem. But if it were to lose power on track power, essentially the whole engine would die and it wouldn't be a problem. But that doesn't take into account the fact that the trucks might run at slightly different speeds and put load on the drive shaft. And the newer Bachmann Climaxes actually have just the front truck driving the drive line, and the rear, it's just an idler that's spinning for looks. So when these engines were having this issue, Bachmann released a part that was this rear drive shaft here. And on the stock engine, the way it is now, this rear drive shaft is a solid piece all the way to the end. It's all metal the whole way. But what Bachmann did is they started selling this part with a little bit of plastic on the end. Essentially, this drive shaft has a round shaft that this piece of plastic presses onto. And then the motor from the rear truck is spinning just this part. And then the front truck spins the rest of the drive shaft, including the engine set. So that solved the problem of the engine binding up if it were to lose power without having to change any of the electrical characteristics or mechanical characteristics of how the locomotive was set up from the factory. And this part that I'm holding is actually still available from Bachmann with that little idler bit on the end. So if you have an older Bachmann engine that has this problem, you can actually still buy this part. It's one of the few parts you can get factory from Bachmann today. And this ultimately solves the problem, except for the fact that on our engine the damage was already done with the gears. So now, after this somewhat long technical explanation that hopefully will give everyone an understanding of why we're doing what we're doing and the problems that these engines initially had and the fix that Bachmann put out for them, we're now going to use the parts off of this donor to fix this locomotive, because whoever owned this engine before did not put that part in, and the damage was already done. It already stripped the gears out. And so the donation parts from this engine is going to make this one functional. And that drive shaft ultimately is the answer to make everything work correctly. So now we're going to dig into the trucks, put those new gears in, put that updated drive shaft on, and see how it all works mechanically. Prior to us putting this new drive shaft on, I actually powered the locomotive up and tested some things real quick. And the good news is the rear truck actually still has a good drive gear in it. And even if it's starting to head south, that's okay, because all it has to do is spin just this universal and that little tiny bit of drive shaft right there. So it doesn't have the load of the whole engine set on it. So with that knowledge now that the rear truck is good and the front truck is the one that's messed up, we can proceed with the installation as planned, and it's actually a lot easier because we don't have to swap any parts from the front to the rear truck. But quickly, just to illustrate, here is the old drive shaft. As you can see, it's solid the whole way across where it plugged into this square shaft here. And this is the new part with the slipping end to it that will allow this all to work. So the first thing we're going to do is take off the screws on this universal joint right here, which will allow us to take that long drive shaft off. We'll put the new part on, and then we'll move on to the front truck and put in the new gear on the front truck and see how everything works. So all we need to do is take the two screws off to hold this universal on. There's one right here, and then one opposite on the other side. And the whole thing just pulls off. And then there's also locator pins that I'll show on it. And those locator pins will help it get back into the correct location when we put it all back together. So now we will take the old drive shaft out. And it's just as simple as slipping the new drive shaft in, like that, and then we'll put it all back together. One good way to get things started is if you put a pair of needle nose pliers, for instance, or something to keep this universal from rocking back and forth. It'll keep pressure against the horn that's coming off the engine set and make it a whole lot easier to get the pins in place, because you're ultimately pressing and putting pressure on it, and it wants to just slip off when you do that. And there we go. So now we'll get the first screw started. It's a little tedious. So through the magic of video editing, we now have the screws in. They were a little bit of a pain to get in the position they were in, but we got it all together. So now it's as easy as just reconnecting the drive shaft by turning the truck and connecting it right there. And as you can see, now this whole engine set spins independently of that rear truck's drive shaft. So now we'll move on to the front truck, and basically there's a plate that screws onto the back of the truck here that mounts the gear on the drive shaft that then connects to all the gears up here in the gearbox that actually drive the wheels and then in turn drives the drive shaft and the engine set. In theory, we're going to be able to do this without taking the truck back off the engine. And if we have to take the truck off the engine, it's not the end of the world. It just adds a little more time to the process. So there's just 2 screws back here that hold the plate on. So we'll take those off. And there's the second one. And then in theory, the plate just pulls out. And as you can see, the whole shaft pulled out that time because it was actually broken. And there was supposed to be a screw there holding all that together. But with a pair of pliers, we should be able to work that out. Like that. And so that's the gear right there. And this gear actually has quite a few flats on it from where it has chipped and worn over the years. So now we're going to take that same part that's complete off of the donor engine. We're going to screw it back into that same spot, and then we're going to test everything out and see if it works. And now we have the part off the donor all complete, and it just slides in like so. And then we will replace those screws. They're right down here. And then in theory, we can give it a test and see what happens. So we got the Bluenami app pulled up on the phone, and we're now going to turn the locomotive on and test it out. And this is the moment of truth. And there we go. I'm going to try it the other way. Looks pretty good. Truth be told, that was not actually the official moment of truth. The first time that I put that gear in, it turned out the engine still would not run. It was clicking and having all sorts of other problems. The gear was essentially skipping. And it turns out that one of the gears from the parts donor locomotive over behind me was also bad. So I did some cobbling together of different parts, tried swapping some trucks around and doing all sorts of various things, and finally found a combination of parts that worked. And good thing it did, because that was my last idea to get it to work without having to go out and source new parts, like having someone make them or finding another locomotive. Needless to say, these older Climaxes are real finicky. If you can find some new trucks, those die-cast trucks I was talking about, get them. That's the way to go. They're bulletproof. These ones, not so much. But it appears we've found a combination that'll work. And so now it's running, so we're actually going to be able to put some of the detail parts back on it. And then at that point, it'll be ready to go for a test run on the Fern Creek and Western. It's very common for detail parts to go missing on these locomotives, as they are fairly fragile and detail parts do come off somewhat regularly with rough handling. Some of the parts would be easy to reconstruct. such as these right here. These are the branch pipes. On a real locomotive, these would feed the water from the water injector in the cab up to the boiler through the check valve and then the stop valve that they use to shut off the branch pipe at night. Those could be bent with brass wire. The valves are readily available. But some of the more complicated parts, like this casting here that's actually the cylinder cap, that would be hard to make. About the only way to do that would be 3D printing. So luckily we have this parts donor engine, and maybe in the future to replace the parts on the donor engine, we'll do a segment about 3D printing or something. But we're going to put these parts on. As I mentioned, these are the injector branch pipes, and this is the cylinder cap. This is a brake beam here. We were missing one brake beam off the locomotive. It's got the brake shoes on it, and it clips into the hangers that are on the rear truck where they're missing. These are both the coupler boxes. You may have noticed that there are couplers on the locomotive currently, but those are truck mount couplers. The boxes mount to the end beams of the locomotive, and not only are they decorative and look much better with them on the engine, but you can actually mount a coupler in them. I use a KD904, KD couplers that basically have a long shank on them, and you can cut the end of the shank off. They don't have a hole or anything for mounting in a box. Cut the shank off, and then you drill a hole in it for this little pin to go through and round the edges off so it's able to turn inside the box. And it looks really sharp. It looks absolutely to scale. And better yet, without the truck mount couplers, the engine operates far better, because the truck mount couplers are notorious in any scale virtually for pushing cars off the track. And with our switchback, for instance, on the Fern Creek and Western, it's not possible to use truck mount couplers. It'll just derail constantly. So this will make the engine far more operationally reliable, and it'll also look a whole lot better. So I don't have the couplers themselves at the moment. They're actually back at the railroad, and hopefully we'll have them mounted before we run the engine on the railroad. But for now, we'll just put the boxes on. The final bits off the donor engine are going to be the pipe for the blower that's down here that mounts into the smoke box, as well as the headlight bracket. As you can see, this headlight bracket is broken on one side. At the rear of the engine, these are actually the holes that the screws go through to screw the tender to the frame, and those water shutoffs are not only a decorative bit that would have been on the prototype, but they also plug those holes so you don't have to see them. The final thing is the boards and coal pile that go into the cab. That's missing on this locomotive, and it covers up all the wires that come from the bottom of the frame and into the tender. So we're going to put the branch pipe on now. It threads into the cab. There's a hole in the cab wall for it to go into. And then the other end just threads into the hole that's on the boiler. Like that. And it's the same process on the other side. And this one's really easy. This is the valve cover. It just simply has these two tabs that press in right here. So changing out the headlight bracket is a slightly more involved process, because we're going to have to cut the wires that go to the headlight, put the new bracket on, and then reconnect the wires. So I'm going to take the smoke box front off, which is just simple as pulling the whole front bit off the locomotive. This is just a press fit piece. And then pull a little bit of slack out of the wires, just enough that we can cut them. And we don't want to cut too far back, because then we'll never be able to get back at them again with the soldering iron. So we'll just cut them kind of up towards the front here. There. Now this old bracket will just pull out like that, and there's the broken piece. So now we'll bring the new bracket in, test fit it. And you can see it just presses right in there. And then this headlight has a screw in the bottom of it that we need to remove, and then we will put it onto the new bracket and screw it back in. And there we go, the new bracket's ready for use. So the wires are all soldered in, and I've put heat shrink tubing on them to protect everything, and now all we need to do is just seal the front back up, and we'll be good to go. So we'll also install this blower pipe, which just threads in through all of the other piping that's here. There's a little hole right next to the firebox there. And then the front end of it just presses into the side of the smoke box, like so. So for putting the brake beam on, we actually have to take the bottom cover plate off of the truck. We're not going to take it off all the way, but just enough that we can slip the new beam on. Would it have been more efficient to do this when I had all the trucks apart? Probably. But I didn't think about it at that point. So when you're putting the beam on, it goes with these little holes pointed up because they slip into these little metal brackets right here, which are called the brake hangers. And so we have to first slip them onto the metal brackets. And we'll use a pair of tweezers to spread the hangers. And as you can see, then it just pops on like that, and now it's hung on the hanger. So we'll do the same thing on the other side. And then there's two tabs right here, and those slide into little slots that are under the cover plate. And the cover plate clamps down around those slots, and these little end stop pieces keep it from popping out. So now we'll just, without having to take the cover plate all the way off, we'll just pry up on the cover plate and set that in, and then we'll screw the plate back on. It's really neat. So to put the new coupler boxes we have on the front of the locomotive, or coupler pockets I should say, we have to remove these two screws that hold this cover plate onto the bottom of the end beam. So it's just as simple as unscrewing those two screws. And then that little cover plate will pop off and reveal a little slot that the coupler pocket actually slides up into. Now it appears that the original owner of the locomotive actually glued the old coupler boxes in, and they were broken off at some point. So we might have to do a little bit of glue cleanup or something like that to get them to fit right. There we go. Yep, there is definitely glue in there. So I've cleaned the glue out of the slot, so now there's a little tab on the back of this coupler box that just slides up into that little slot. And it takes a little bit of force to push it up there, but it just slides in like that. And it's the exact same process on the back. So now we're going to put the cover plate back on, and we're going to move on to the final step of putting all the parts on the tender. The final thing we're going to do is to take the tender off the locomotive to put the small coal pile and boards in the front of the tank here to cover up all these wires in the cap. And you got to take the tender off in order to do that. So again, as we've shown before, it's just these two screws down here. So we're just going to slide the boards up against the coal load there, and then the little coal pile in below it, like so. And now we can put the tender back on. And the final thing is to just put the water shutoffs in to cover up those holes, so we don't have to see those ugly screw holes anymore. And like that, she's ready for a road test. So, with everything back together, we're now going to give this thing a test run on an actual piece of track. Runs pretty well overall. So, at this point, we're now on to being able to just do some last-minute programming to it and a few little adjustments, and then we'll take it out on a piece of track that's a little more than 4 feet long and do something with it. So stay tuned, because right now we're heading to the Fern Creek and Western.
Well, all I'm going to say is it's a good thing we had access to a parts donor. Our friend Kevin found it, which just goes to show you can't go wrong if you share your projects with your friends. Speaking of Kevin, one of my favorite shows on this channel documents when Kevin had a 2-truck Shay that he wanted to put a decoder into. I recruited Trevor to help, and the three of us had a great time hanging out and making a video about the process. If you're enjoying this series, I recommend taking a look at that other video. It's a lot of fun, and it shows how to install a decoder for a layout that uses track power. I put a link in the description of this video so it's easy for you to find. Speaking of links, I also added affiliate links to the description here so it's easy to find what you need to do your own battery conversion like what we're covering here. So the model looks way better, and it actually runs now. At this point, I haven't decided on a number for it, but we do need to give it a good test run. So in the next episode, we'll take it to the Fern Creek and Western to see how it looks running on a big garden layout. Trevor has a fully detailed and finished climax that he also wants to show us to provide an example of how good one of these models can look if you take the time and really go all out with it. If you subscribe to the channel, you can be sure not to miss the next episode. Thanks for watching, and I'll see you next time.